Let's create a component that monitors one or two substations transformers. The component, as shown in the figure, is composed of several IEDs. In the example, our component will have 3 IEDs wrapped in red rectangles: voltage regulator, transformers temperatures and environment temperature. The monitor will be located in component asset monitoring, and it will read the transformer monitoring points belonging to the IEDs, and send them to the control center via a DNP 3.0 gateway. The idea, using lean automation, is generate the application in few minutes that has the following advantages. If the communication with the center fails, the component will save the read values in local history file. With more than 1 month, the component will monitor the health of IEDs and alarm possible fails. The component will have dashboard screens, with data from each IED, as well as various reports, alarms, events, operation log, real-time and historical trend, etc. The user can access these screens via tablets or client laptops. Therefore, if there are user locally in the substation, it will access the IED's informations. Initially, we will create the example asset project. And insert the component Spin Smart Sub, which monitors 3 IEDs of the transformer. In the sequence, we define that we will send the monitor data to a center. The application could only monitor the assets locally and generate screens of dashboards, but in the example, we will also transmit the data to the center of assets monitoring. After inserting components into a project, we should always do a project build and check that there are no errors caused by potential conflicts. Let's check out how the transformers template is, by navigating to one of them. Each template is composed of 3 sub-templates, TM, DVR and master temp, which correspond to the 3 IEDs that monitor each transformer. We navigate to the TM subtemplate and see it in 4 monitored variables. In category, we see that they all go to historical, and in comments, we see their address is Modbus, their access type, and the factor scale. Now, we navigate to the DVR subtemplate, and again, we see dozen of variables of this IED, where in category and comments, we see how to treat each variable when they are explode. Finally, we navigate to the master temp IED, and again, we see its variables and rules of how to treat them in the explosion. Now, we navigate to ZZ Asset Trafo. And change the start value of the variable Trafo number to 2, so that a menu of 2 transformers is placed on the initial screen. Now, we change the main screen layout that differs from the default project. Going to the channels screen, we see that all channels of the application were created, but the channels are disabled. Going to nodes, we observe it also was created. On points address, we see that the DNP3 addresses of the gateway server are also created. Once they are defined by the application, each type starts from 1. The Modbus addresses of IEDs will be filled by deploy. The alarm items table is empty. as well as empty the historian tables. Finally, let's run the deploy module that will instantiate the historical tables, alarm items and address points of the IEDs. After execution, we noticed that the historian table was filled, as well as the address points table, and the table of alarm items. Once the component parameterization is complete, let's run and test it. This initial screen shows the general scheme of the transformer, with the monitoring IEDs. The left IED is the voltage regulator and the right IED is transformer's temperatures. Clicking on the IEDs, we navigate to their detail screen. On the left side of the screen, we have the selection of transformer 1 and 2. When we select one of them, we navigate to the transformer screen, similar to the screen shown in the control center. At the top of the screen layout, we have buttons, where the first one, GRID, takes us to the opening screen, and the others, generates the reports designated on the button. When selecting an IED, you must select the desired transformer. In conclusion, within a few minutes we generate an application that, once integrated into the transformer monitoring IEDs, immediately starts reading the IED data and sending it to the control center. If a technician is in the substation, he can via tablet or laptop access dashboards with the transformer monitoring screens. If communication with the center fails, the gateway stores the data locally for more than 1 month. If we register the different IEDs of the transformers as components, we can generate a generic data collection application with several IEDs options in minutes, with minimal possibility of error.